Hi there. In this session we're going to be looking at the object-oriented question 3 from the 2019 September Free State Preliminary paper. This is a modified version of the Northwest paper from 2018, so if you have access to that paper it might look a little bit familiar to you. Right, have a look at the website. You'll find the question paper is in the PDF file and the data files are in the zip files. We're going to be working with question 3. Please extract that in an appropriate folder as I have done here. While we work, I'm going to have the question paper open on the sidebar on the right so we can follow along. Right, question 3b, and that's opened here. Now on the right you'll see we have CLS class.pas. That is the file, the unit file that's going to contain our object that we're going to create, and then form question 3, which has the form that we're going to work with. The form looks like this. It's some sort of timer, and the object file at the moment has just about nothing in it. We've got T examen, 2 fields, and no other code. So let's have a look at what the question requires. So we've been asked to help write a program that can be used to keep time during an exam at school. Learners are not allowed to wear watches. Shame. They have no idea how much time is left during a test, as this program will be projected onto the screen. So we first have to write a mutator method called setTimerLength, which will receive the duration of the question paper as a string and make it globally available by assigning it to fStartTime. One of the keywords you look for is whether this returns a value. In this case, it does not return a value. That means we're using a procedure. Mutator is another word for something which changes values, a setter in some terminology, and that also means procedure. So set timer length, we have duration, and that is going to be a string, and we're going to set fStartTime. fStartTime, you'll notice, is also a string, so we'll work with that. Shift-Control-C, remember, is the shortcut to create the procedure for you. If for some reason in your programming you've made an error, you won't be able to use that shortcut key. You'll have to type this out yourself. Procedure T examen, that is the name of our class, dot setTimerLength, the name of the procedure that we're busy creating. Right, this is very simple. I'm going to set fStartTime we're going to set fStartTime to the duration string that got passed in the parameter that I created. Question 3.2. Write a method called calculateEndTime. This doesn't receive any parameters and uses the current system time to determine what time it currently is. Then add duration of the paper to the time to calculate at what time the paper should be finished. This value is stored as fEndTime. Again, it doesn't say that this must return a value. We are instead setting the field that is fEndTime. So this will be a procedure. It is calculate end time. It has no parameters. Shift-Control-C again. And we're going to have to do a few things in this particular procedure. The first one is we're going to have to get the current time. Get current time. The second one is we're going to have to convert that duration into something appropriate. Remember, the duration is stored in F start time, and then we're going to have to add the two things together to give me my final F end time. And F end time is stored as a string, so I'm going to have to convert this calculation back into a time. That means I'm going to need some variables. The first variable will be the current time, and that will be a t-date time. There we go. We need to convert that duration into a t-date time as well. So let's give myself a variable duration. Might be nicer to spell it correctly. And we can use string to time. Remember, that is stored in the F start time field. To calculate the duration, I'm now going to add these two together and set my F end time. And I can reverse this procedure. This is going to be time to string. So that'll be current time plus duration. And that should complete this procedure. Again, you can do it all in one line if you really feel like doing that, but I prefer to split up this sort of calculation, partly to make it easier to read, and partly so that if I make a mistake somewhere, it's easier to identify a discrete line, discrete part of the calculation where the error occurs. 3.3. Write an accessor method called getTimeDiff, which will subtract the current system time from the calculated end time. This method doesn't receive any parameters and will return a string value. Notice the keyword return. As soon as you have return in the question, you know you have to use a function. This is an accessor. So, function with a C, getTimeDiff, and this will return a string. Shift Control C again to create the implementation. Right. We're going to have to do some converting again. We're going to subtract the current time from the calculated end time. So, var, I want end time as a t-date time. I'm also going to have current time as a t-date time. End time is going to be string to time if end time. Current time is going to be now, the time now. And our result is going to be this as a string again, so I've got to reverse the calculation. Time to string, end time minus current time. There we go. 3.4. Write an accessor. Accessor again means something that gets a value, a getter, so that will be a function. ToString, which will call getTimeDiff and send the value to the main program. I have trouble seeing why this particular routine is necessary. You already have getTimeDiff, which is returning a string value, but this is what we are asked to do, so let's do it. Function to string. It doesn't ask us to do any extra processing. We're going to be returning a string value. Shift Control C, and result equals getTimeDiff. That's how it stays. Right, 3.5, write the accessor method. Accessor again means a function. Test valid, which will determine if a given time is entered in the correct format. Please note, this method doesn't receive any parameters. It will be used to test if start time is in the correct format. This method will return a Boolean answer. And we're given a hint. They won't always be this friendly, but they say use a temporary variable and assign the fStart value to it for the purpose of this validity test. The reason for that is if we are going to be doing something like a pos copy delete string separation routine, we don't want to be deleting anything from the actual data. We may need to refer to this later. Anyway, over here. And just checking to see they don't say that this must be a private function, so function test valid with no parameters, and it's going to return Boolean. Shift Control C again. Let's create that temporary variable. Which is a string, and we're going to set GMP time, if start time, and we can work with this. The first one is we have to test whether this is 8 characters. If length GMP time is different to 8, again, result false, and exit. There are other ways of doing this routine. You can test whether it equals 8, and then inside the if statement do your tests. I prefer to return and exit as fast as I can, so that I don't have to worry about miscellaneous ends and so on. It's a personal preference. There should be 2 colon signs. This may depend a little bit on the system time format on your computer, but most use a colon, as you can see in the time in the top right hand side on the screen that I'm working with. So now we have to test to see whether it matches the second part. There should be 2 colon signs, and only numbers are allowed. Now it's going to be 8 digits long, which means it's going to follow this pattern. That's what a time statement has to look like, a time string. So right off the bat, we know the colons have to be at position number 3 and position number 6. We can test that easily enough. If GMP time 3 is different to colon, or GMP time 6 is different to a colon, then I know it's not a valid time. This is a Boolean expression with 2 parts, so I'll have to use parentheses just to make sure these are executed correctly, evaluated correctly. There we go. And following the same procedure. I can exit the loop if they are not valid. Now we just have to test the numbers, and the easiest way actually is to delete the colons and see if we have a number left. Otherwise I would have to separate out the first number, evaluate that, separate out the second number, evaluate that, separate out the third number, evaluate that, and then generate my result. So let's use the hint they gave me, use TMP time and delete the colons. Delete from TMP time. We know this has to be at the third character, and we're going to delete 1. I'm also going to delete from TMP time at the 6th character. There we are. And now I must test to see whether this is a number. We don't use it very often, but the val function, val procedure rather, will do this test for me. I'm going to try and convert TMP time into a integer value. The nice thing about the val procedure, old and slightly depreciated though it is that it gives you a error code which you can use to test whether this was a number or not. So let's store this as an integer, I time, comma, I error, both integers. Val is quite flexible. You can use it with real numbers as well as integers, as I'm doing here. The error code is always an integer. And if you have a partial string that works, 1, 2, 3a, this will convert the 1, 2, 3 portion and generate an error code. So you get a partial conversion. Anyway, we're only interested in whether the entire thing is fine. So if I error is bigger than 0, then I know that there's a problem with this particular number. And if we get to this point, then I know there's no problem, so result equals true. And there we go. Save. Now, I'm not sure how that's going to be used because there was no indication that we had to use that in any of the earlier routines. So now we're going to have a look at the second half of the object-oriented question. Remember, object-oriented questions always come in two halves. The first half is the one we've just been working with, where we set up the class definition. The second half of the question is the half where we're going to use it. And that will refer to form question 3, the form that we're going to be working with. So let's have a look at what we've got here. We told, note, the class has already been created and connected, and that is what is happening here. Part of our form is a instance of the class that we were working on. Right, when the button begin button is clicked, do the following. So we're going to find button begin, that's there, and that takes us here. Get the time entered by the user from the edit time component and send this value to the class unit by calling the appropriate method. So edt time is that one, and you'll see it's in a hours, minutes, seconds format. We're going to send that to class. This class has not yet been instantiated, so we're going to have to do that as well. That means class is texamen dot create. And notice, even though we did not explicitly create a constructor for this class. There is no create constructor defined here. Delphi has a implicit create, which is used in this case to instantiate the class. Next, we're going to call the option to send this value to our class. So class.setTimerLength, and this will be from edtTime.text. Now that that is part of our class, we can use testValid. testValid refers to the value that is stored in our component. So let's see. If class.testValid, then if it is valid, we're going to enable the timer component. If it's not valid, we're going to display a suitable method. So first, let's get the message out of the way. Begin. They don't say how we're supposed to display the message or what it's supposed to look like. So show message time is invalid. If we used a message dialog, then we could have a little nice big red cross telling people they've done something silly. But we're not going to worry about it now. Okay. And otherwise, we must enable the timer component. So tmr time dot enabled. There we go. Equals true. 3.7. The timer time component will execute every second. Write the code in the timer time component which will update the time. Okay, so let's go to the timer component. There we go. And over here we're going to have to update the label by calling the appropriate method. Label time dot caption colon equals that's class dot, and we can use the toString method there. I left something out in 3.6. In 3.6, we mustn't just enable the timer, we must also set the end time. So that's class dot calculate end time. There we go. So toString calls get time diff. Get time diff, calculates the time automatically. This should work. Let's cross our fingers and see what happens. And I'm going to say 1 hour. Begin. Time is invalid. That means there's something wrong in my validate time routine. Let's stop this program and have a look there quickly. If I go to class here, that's the validate time routine. I'm going to put a little stop at the beginning of it, just so we can see what's happening. 01 colon 00 colon 00. Begin, and we pass that test, If you have a look on the left hand side here, you will see the time changing, and the first colon is deleted and the second colon is not deleted, and that's because I forgot that when the first colon is deleted, this has a different position. That would move up one. I could have avoided that by using the pos function when calculating these times, but seeing as the positions are known, that isn't absolutely necessary. 1. Let's run this again. Just test. Use the same example. 0, 1, colon, 0, 0, colon, 0, 0, and begin. And there we are. That's the end of that question. In the next one, we'll have a look at the text and array question, text file and array question, question number 4. So, I'll see you again shortly. Bye for now.